All right, this video is going to deal with one more quick result about polynomials and dividing by linear monic terms, that x minus a term. So this time we need a definition that you're familiar with. A root of a polynomial is a number a, so that f of a equals 0. So that's all this definition is defining a root of a polynomial. And then the lemma has to do with that. And again, this is something you're familiar with. So this says that a is a root if and only if f of x is q of x times x minus a. So that is the remainder, the r of x function here is 0. All right, so we're going to prove this. This is an if and only if statement. So that means there are two directions. This says if a is a root, then f of x equals q of x times x minus a. And then it also says the opposite direction. It says if f of x equals q of x times x minus a, then a is a root of the polynomial. And so we're going to prove these two statements, and I'm going to kind of notate them with the little forward arrow or backward arrow so we remember what we're proving. So let's do the forward arrow first. So this is, we're going to posing the if. We're going to say assume a is a root of f of x. And what that means is that f of a is 0. Okay? Then by this lemma, and that previous thing was called the remainder theorem. I'm not sure if it's labeled that in the book. But that's what it's known by sometimes. Then if we write f of x equals q of x times x minus a plus r of x, we know r of x is equal to f of a, which is 0. So what we have is exactly what we want, that f of x is q of x times x minus a. Okay, so that's the forward direction. That's the if a is a root, then f of x equals q of x times x minus a bit. And now let's do the opposite direction, the backwards direction. So here we're going to suppose that f of x equals q of x times x minus a. Now, if we plug in a, we get that f of a is q of a times a minus a, which is q of a times 0, which is 0. So since f of a is 0, a is a root. A is a root of f of x. So this is a pretty easy result, and it's one that you know. If you have a root of a polynomial, it means you can factor out that x minus a term. And that actually brings us to our next definition. We can use this divides language like we used with integers in polynomials. So if you can write f of x as q of x times g of x, then you say g of x divides f or is a factor of f. All right, and now the last little bit of this video is just looking at this lemma. So the lemma says if d divides a and d divides b, so d is a factor of both polynomials a and polynomial b, it's a common factor, then for any p and q, d divides p times a plus q times b. This is really similar to lemma 1.2 in the integers. We had the exact same thing, but without all the functions. They were just integers in that setting. I'm going to have you prove this for a homework assignment. The proof is going to be pretty similar to lemma 1.2, and you can look at that proof if you want. It should be a pretty quick one to write up.